In this video, we're going to be looking at compound interest. Now, compound interest occurs mostly in bank accounts where you are putting money in and then it's growing over time. It's very different to simple interest. And if you haven't watched the video already, go back and watch the video that I made recently on simple interest. Simple interest is when it just grows at the same amount each time. So $500, $600 each month, that's what the bank pays you. Compound interest is where the interest that you get also grows. So maybe in the first month you get $50, then in the second month you get 52, then 54, 56, and so on. So compound interest is growth over time. And the formula for compound interest is this. The amount that you have in your bank is the initial amount times 1 plus r over 100 to the power t. And r is the percentage that they give you. Sometimes it's I, sometimes it's r, it can be any letter. Now, let's say that we invest $3,000 in a bank account, and the bank account pays you 3% compound interest. You may even see the words per annum or PA, and that means per year. It's compounded once a year. Over the course of the year, the bank will give you 3% interest. So in the first year, if you wanted to calculate it, we'll do 3,000 times 0.03, and that gives you $90 times 0.03, and that gives you $90. That's the interest they pay you in the first amount, in the first year. So after the first year, you have $3,090. In the second year, you have $3,090 times 0.03, which we get in our calculator. 3090 times 0.03 is now 92.7. So you can see that they're paying you more. In the first year, they're paying you $90, and then the next year, they're paying you 92.7. And that interest is growing over time. Let's say that the $3,000 is compounded at 3% for 10 years. So we'll use the formula a naught 1 plus r over 100 to the power t. And we're going to do it for 10 years. That's a t. So we'll take a naught, which is the initial amount, 3,000. We'll do 1 plus 3% over 100 to the power 10. And if you want to, you can simplify it down. If you think about when we're doing the percentage increase and decrease, if you haven't done so, go watch the video on it. We can just write 1 plus 3 over 100 as 1.03 because it's a growth. So we'll do 3,000 times 1.03 to the power 10. Get your calculator, put it in, power 10, and that will be 4,031.75. Let's now say I wanted to know how long it will take to double. So now I want to solve an equation for t, because I don't know how long it's going to take, but I know the final amount. If I'm doubling it and it was initially 3,000, the final amount will be 6,000. So using the same formula, I can make an equation. 6,000 is a naught, which is 3,000, times 1.03 to the power t. Or 2 is 1.03 to the power t. And all we're going to do, and that's just by dividing by 3,000, all we're going to do is we're going to put numbers in our calculator until I get just above 2. Let's start with 20. So I do 1.03 to the power 20. I'm just going to guess and see how much that is. That's 1.81. Now that was just a guess. You could have started at 10, but we know that with 10 years we only had 4,000. So it's a good idea to try something slightly larger. Let's try 1.03 to the power 25. That gives me 2.09. So you know that's too large. Let's try 1.03 to the power 23. That would be 1.97. That one's too small, so therefore we should just try 24 and see which one it is. 1.03 to the power 24 is 2.03. So we know that at 23 years, it's not enough, and at 24, it's too much. So therefore, in the 24th year, after 24 years, you will have doubled your money, because in 23 years, it's not quite enough. Let's do one more example. Let's say that I've got $5,000 in a bank account making 7% interest per year, and I'm going to invest it for 15 years. Well, I do 5,000. The growth at 7%, so I do 1.07 to the power of 15. And I put that in my calculator, and that leaves me with 13,795.18. And obviously, if we're dealing with dollars, we need to be rounding to 2 decimal places.